Hello students, today we'll discuss the topic of coagulation and flocculation. Myself, Professor Renuka Nirbanayake. We have already studied the part of sedimentation tank and its design. So in this topic, we have to know regarding coagulation definition, and then we have to discuss regarding diffuse layer theory. So in this coagulation it is derived from the Latin word coagulare, meaning to drive together. Colloidal particles carry electrical charges on them, and as such they are in continuous motion and never settle down under gravity in a reasonable period. Coagulation is a chemical process in which these charged colloidal particles are neutralized and destabilized. So, the process of mixing certain chemicals to water to neutralize the electrical charge and to form insoluble gelatinous flocculant precipitate for absorbing and entraining suspended and colloidal particles of impurities is called coagulation. So, water contains a wide variety of suspended particles like clay, silt, very fine silt, algae, bacteria, and other matter. These particles may have size ranging from 10 raised to 2 to 10 raised to minus 7 centimeter. Many of the impurities are too small to be settled out by gravitation in settling tanks. That's why effective settling aggregation of these small particles into large and more readily settleable solids is necessary. And this is done by using some chemicals which are called coagulants. So as discussed, particles which are just big enough to have surface which is micro capability observable or which is capable of absorption of another phase, that is the size which is nearly about 0.01 micron to 1 micron and having surface area 1 square yard to 1 acre per gram. So now we have to discuss regarding diffuse electrical double layer theory. It states that the stability of colloidal particle depends upon the electric charge that they carry or they possess. The primary charge of colloidal particles may be due to charged groups within the particle surface or due to adsorption of layer of ions from the surrounding medium. These primary charges counterbalanced by ions of opposite charge in water phase. Electrical double layer is a formation of interface between water and solid, which you can see in the next figure. Double layer consists of charged colloidal particle. Second, an equivalent excess of oppositely charged counter ions which accumulate in the water near the surface particle. So remember students, double layer consists of charged colloidal particle. That means electronegative particle we can see in this figure, which is electro having negative charge to the colloidal particle, like clay particle. Simple clay particles having this electronegative particle. When we will add coagulant into the water, it have positive charge. Then in this double layer theory, the counter ions are attracted electrostatically to the particle surface and cause high concentration at the particle surface. Concentration decreases as the distance increases from the solid water surface. That means Negative, positive, negative, positive, the such diffuse layer will be formed. In this figure, we can see fixed layer is formed due to attraction of positive coagulant particle, and it will increase the potential, which is zeta potential, and negative positive, such diffuse formation will be carried out at double layer, at boundary layer. So it will increase the potential, and that is surface potential. This decrease or diffusion of counter ions may be due to ejection and replacement by other ions. When water contains high concentration of such counter ions, the diffuse layer is compacted. This expansion of stability of colloidal particle is nothing but diffuse double layer theory. So students, you should understand that an electric double layer consists of three parts. First, surface charge, second, second layer, and third, diffuse layer. So surface charge means its own charge, that is colloidal particle having negative their own charge, which is adsorbed to the particle. And stern layer, that means when in coagulated process, when we are adding coagulant which having attraction of opposite charge particle, that is counter ions, which is attracted to the second layer. Counter ions attach or attract particle surface and closely attached to it by the electrostatic force. And diffuse layer, that means combination of both negative and positive, that means counter ions molecules into that. This diffuse layer contains free ions with high concentration of counter ions. So the ions of diffuse layer are affected by electrostatic force of charged particles. You should remember this all. So students, this is very nice figure in which coagulation aim is explained very well manner. As shown in this figure, coagulants are added into the tank. You can see the impurities by the red dots. When coagulant added into the water, this double layer theory formation is takes place. Means negative colloidal particles were attracted to positive charged counter ions which having higher valency. Coagulant forms precipitate, that means unsettlable gelatinous mass formation will be takes place, and it will increases the potential of and increases the agglomeration, and due to that precipitation a precipitation will be formed by trapping those impurities, and accumulation will take place at the bottom of the tank. In the next image you can see the formation of double layer. So negative charge particle with cloud of counter ions will be formed, that is nothing but the negative charge of colloidal particle will attracted to this counter ions having higher valency. That means when alum is added into the water, alum having potency of 3 valency, and it will counter it will formation of agglomeration by negative positive charged. It will neutralize the formation, and neutralize due to neutralization agglomeration agglomeration means accumulation will be takes place during this coagulation. we should know various factors affecting coagulation process. So first is the type of coagulant. That means when we are adding coagulant into the water for coagulation process, there are various types of coagulant like ferric salts and alum salts, or the different coagulant like polyelectrolytes and nitrocoagulant also. So that coagulant type is first important factor. Second, dose of coagulant. That means whatever the coagulant we are adding, that's concentration and quantity is key element factor for coagulation process. Then characteristics of water like kind of and quantity of suspended matter present into the water. Next, temperature and pH. Then, whatever turbulence and method of mixing is carried out, and for how much time we are adding coagulant, that is also very much important for into the coagulation process. We should know what are the different common coagulants are used in coagulation process. Those are alum, ferric sulfate, ferric chloride, ferrous sulfate, and sodium aluminate, as well as chlorinated copperas, magnesium carbonate, ferrous sulfate and lime, magnesium, magnesium carbonate and lime, sodium aluminate, as well as polyelectrolytes. So in this PPT, we can see the common coagulant, most probably it is used alum. When alum is added into the water, what chemical reaction it is, which is very much important to understand. In this, we can see first four coagulants have lower alkalinity and pH of solution, while sodium aluminate will add alkalinity and which increases pH. So when alum is added into the water, it will react with bicarbonate alkalinity is present in water. So as we know that bicarbonates of alkalinity having two types, calcium bicarbonate and magnesium bicarbonate. So when alum is added into the water, it will react with calcium bicarbonate, which is present in water, and forms calcium sulfate, and the flow formation will take place, which is in the form of aluminum hydroxide. And during this process, 6 molecules of carbon dioxide will released out. So students, alum is easily available and widely used in waterworks. Its chemical composition is Al2SO4 thrice 18H2O. 18H2O we can see. It is effective in pH range of 6.5 to 8.5. Alum produces good flock in the alkaline range as discussed. Many waterworks have whenever we mix the alum into water, in water bicarbonates of alkalinity naturally present into them and it will react with those composition. When alum is added, flock in form of aluminum hydroxide AlOH3 is formed. This flock attracts colloidal suspended matter, grow in size and finally settles down. That means gelatinous mass of aluminum hydroxide is formed and this chemical reaction is taken place. I hope you understood chemical reaction of alum. So coagulation process is carried out by 4 steps. First, feeding. That means addition of coagulant which are either dry or wet form. Then mixing and whatever the coagulant you have added either in powder or liquid which is to be mixed in a proper way. That is carried out by various ways like compressed air device, centrifugal pump, mixing channel with vertical baffle plates or sometimes horizontal plates, then mixing channel with mechanical means. Third step is flocculation and fourth is clarification. Actually, dry fitting is carried out by two ways. First, by using tooth wheel or second by helical screw. Each unit consists of conical hopper tanks in which coagulant in powdered form is placed and is allowed to fall in mixing basins, in which agitating plates to prevent arching of powdered chemical are provided inside the tank. Whatever the dose of coagulant is regulated by speed of throttle or helical screw mechanism. The mechanism in terms is connected to the Venturi devices in raw water pipe or mixing device. Second is wet feeding. In wet feeding, the solution of the coagulant of required strength is made and stored in tank. As shown in figure, it is carried out by pulley and conical plug arrangement. So there is adjustment conical plug arrangement is provided to control the addition of coagulant in proportion to water flow. Means whatever the flow, as per the flow, conical plug is pulled by this pulley and due to float arrangement to the rod, only that much of coagulant is added into the raw water channel. This will be carried out in this wet feeding. In this second type, which is nothing but the feeding by adjustable weir, there is an adjustable weir and float device. Adjustable weir is in the form of sliding cylinder with rectangular holes of its surface. The raw water channel and float channel are interconnected to control dose of coagulant automatically. Both these devices are you can see in this image. So other ways of mixing devices are channel with baffle valves, overflow weir and hydraulic jump mixing, which you can see in this images. At last, mixing basin with the mechanical device, you can also call it flash mixer. This is the best type of mixing device and it's used in modern and large water treatment plants. It consists of cylindrical tank, the paddle or impeller which is fixed to shaft and it is driven by electrical drive unit at high rotating speed. The coagulant is added at the tip of the paddle which is rotating one. The water is admitted from inlet pipe. You can see in this image, inlet pipe is provided at the top. Flash mix or flash mixer, water goes to flocculator to outlet pipe. The speed of paddle is in between nearly 100 to 200 rotation per minute, that is RPM. The detention time is nearly 30 to 60 seconds. Ratio of height of tank is 1:1 or 3:1. The value of mean velocity gradient, which is So students, we have to understand the concept of mean velocity gradient. It is already discussed that the flocculation is controlled motion of water assisting formation of the floc. The rate of flocculation depends upon the factors like turbidity, type of coagulant and its dose, and most important, mean velocity gradient. So you should know what is mean velocity gradient. Mean velocity gradient is defined as rate of change of velocity per unit distance normal to the section, that is meter per second per meter. Hence its unit is per second.